Greetings, Tezos Nation. I'm Stu from the Tezos Commons. Joining me today is Didier Plaindoux, manager of LIGO Lang, the smart contract coding language for developing pretty much anything in the Tezos ecosystem. On today's stream, we'll be giving away a Tezos branded Nano Ledger to one of our lucky live stream viewers. If you'd like that lucky viewer to be you, keep an ear out for a keyword later on during the stream. And of course, if you have any questions for Didier that you'd like me to ask, please add them in the chat at any time, and we'll get to as many as we can before we wrap up. Hi, Didier. How are things in France?
Well. New things. We know, you know, that we have a brand new president. Sorry, not so new because it's another. What is once again we are going to play with the same president. That's all, and it's a rainy day, so it's not so how to say. It's not, we're waiting for the sun. So
Not
this is
ideal.
not ideal. Yes, that's right.
To start us off, can you tell us a little bit about your background and how you became involved with Tezos?
For short, so first I have a PhD, so PhD on programming languages with some specific skills on type checker, so with theoretical aspects. Type checker, virtual machine and compilation related to logical programming like Prolog and so on. The language which has been abandoned, which is not yet really used right now because artificial intelligence take the place. This is life. That's life. I hope that Prolog should be reused soon. I don't see any. I don't see it right now. Then after, I worked for different companies. And the most important companies was Fujitsu. So I joined Fujitsu in the research and development team, and we're working for during 10 years. Mostly 10 years on grid computing. So we have a transition in computer science where first grid computing and then after cloud computing. The grid computing is really dedicated to scientific computations, for example, like for the atomic research and something like this. And they need a lot of resources. When I say a lot of resources, it's 1,000 CPUs and so on. So it's really a complex mechanism. So you need schedulers and so on. And then after, I only work for two companies at the beginning. And then after, I start some activities like as a freelance. So I'm doing freelancing. Working on different projects like security, but also distributed system, mobile application, and so on. So different aspects of programming. So I'm using a lot of programming languages. And 2 years before, I'm starting to work for a French startup which is dedicated to real estate and to have to green loan in order to facilitate the case to have a green loan. So I'm going to see if we can have some relationship with some kind of application which are available and should be available on blockchain. And so I'm working for this company which is really Imofix it's a part-time work, and in October I start some discussion just because I would like to change my mind. Start some discussion with Gabriel Alfour, which is the founder of LIGO Lang and LIGO, and also Marigold. And so he decided to give me the capability, opportunity to be the manager of this company. So for me, it's really brand new because my background is really a developer. So I'm really a developer, and here I try to learn and try to play the role of manager. And this is really brand new for me. And same as it's a part-time. So I'm still freelancing. So I'm still a freelancer. So I have different activities, just in order to be sure that I'm not going to be, how to say, upset by different activities and so on, and just to change also my mind day by day. So I'm working for LIGO 3 day per week, and the rest of the time I'm still working for big companies like Airbus and so on, because I'm living in Toulouse. So living in Toulouse without working for Airbus, it's really impossible. And when you are in the technology and the developer side, so this is quite a quick overview of my life. And right now I'm quite old because I'm 54 years old, so I'm a whole developer.
So you're actually quite new to Tezos.
Yes, quite new, because I'm working on for Tezos. I'm starting this job in October of the last year. So I'm work for Tezos and mainly for LIGO during 6 months, is no more no less. So I'm really quite new. So for me, there's a lot of things which are brand new. So for example, the blockchain is a brand new for me. I read some paper, but I don't really dig the subject and don't really try to understand the order and the underlying mechanism, and also the consequences of the society when we use such technologies. Sorry.
Well, as somebody who is quite new to Tezos but comes with 54 years of experience and an extensive computer science background, what are your general thoughts on Tezos and what you've seen so far since you've entered the ecosystem?
So the transition has been quite violent, because before working for Tezos, for me the blockchain is just another buzzword. To be honest, everybody is talking about blockchain every day, NFT everywhere. Okay, but I don't understand exactly what it means, because I don't really try to understand it. The same as, for example, big data 4 years before, and so on. And then after, when I start to work for Tezos and mainly for LIGO, because I discover Tezos through LIGO, because LIGO is a programming language. So as already mentioned, I work and I have the PhD on programming language. For me, it's a good opportunity to work on a project which is a programming, and to help on the design and adoption of the language. And I discovered Tezos through the usage and how to say, the smart contract can be built and be written thanks to LIGO. So what I discovered is there's no more single point of decision. So we are nothing. There's no central point for the trust. So trust is on the system. It's fully transparent. So we have a high level of transparency of what's going on the blockchain. And this is quite new, because once we talk about transaction and financial aspects and so on, everything is hidden. You have trapped by central also companies like banks and so on, and you don't know what's going on. So, for example, when you have your money on your account, you don't know what's behind the scene. And here, everything is transparent, and of course, it's highly secured. So it increases our capability to trust the system, the security, the transparency, and this the fact that it's fully distributed. So we learn this, and I also learned how smart contracts is running on top of the blockchain. So it's really difficult to understand, because there's a lot of topics. You have the distribution topics, you have the protocols, you have the the consensus, you have the validation processes and so on, and the capabilities to write programs which run on tops of all these layers. And you have to try to understand all these layers, and it takes time.
It's a lot to learn, isn't it?
Yes, yes. And for me, it's really important because learning, it's my DNA. So I'm learning every day, and here I'm in front of a kind of iceberg. So you see just the high parts, but you have to dig and to understand all the underlying mechanism in order to understand the technical aspect, but also the consequences on the society and what kind of application we can build thanks to this technology. And this is really hard because I'm pretty sure that most of the people are discovering this, and we have to relearn because we have new aspects which are available thanks to the blockchain, which is not the case. For example, we are doing some traditional developer application when you develop some traditional application. For example, when you have to do some transaction, this is in the system and so on. This is really new for me. For me, it's new. For the other, maybe not, but for me, it's quite new. So this is really amazing. For me, amazing. So I think if we have some capability to write application which manipulates, for example, digital assets, and in short, you have some financial aspect like transaction, it can change the rules and open brand new application and change our mind also, and our capability to, how to say, to accept and to see how the trust can be done thanks to this technology. I don't know if the response is it's good enough, but this is
yeah. It's
yeah.
making sense. So for those who might not be familiar, me
Yeah.
being one of them, what exactly is, you mentioned it was a programming language, but what is LIGO Lang, and where does it fit into those processes that you're talking about?
Okay, so first, Legolang has been designed to, it's a smart contract dedicated, right now, it's dedicated to the Tezos blockchain. So what it means, smart contracts, you are writing some piece of code, some program, and this program is compiled to be executed on the blockchain. So what does it mean? It means you have different aspects. First, the execution it can be done thanks to some protocols. So you can access everywhere your contracts. You can execute the contracts giving some parameters, some information. So therefore, you have some behaviors. You have some expected behaviors thanks to the parameters you give to the contract. The contract is linked also to what we call a storage, which is a state of this contract. So the state is living and is linked to the contract, of course, and it's stored in the blockchain. So, and during the execution, once you write the smart contract, you have different aspects. You can deal with transaction. So once you execute the contract, you can have an output, which is the storage, and also a list of operation which should be done and validated by the system. So transaction, for example, you can access also every mechanism which are offered by the platform. Like, for example, I don't know, for example, the chest, for example, some special capabilities, capabilities to trust and to retrieve the owner, the sender, and so on. So try to identify every components which are involved in the process once you are running your contracts. So you have all the system which came and which are accessible thanks to some primitives and some libraries. So this is just the language. And then after so this is LIGO Lang, this is LIGO in general. So a programming language. And then after we build also a lot of, we try to increase the knowledge around Tezos and LIGO, mainly because we would like to push LIGO, like knowledge base and so on, giving some, as we do right now, giving information to people and try to give some how to say, to highlight and to explain what LIGO is, what is the main purpose of this language, and so on. So LIGO without Tezos right now, it's a nonsense. It's a nonsense. So this language has been really designed to be a good choice to write smart contract dedicated to Tezos right now for Tezos. Yeah.
Well, as a programming language,
yes.
What advantages does LIGO Lang have over some of the other programming languages that someone could use?
Oh, it depends. So, for example, in Tezos, we are three languages. The first one is SmartPy, which has been inspired by Python. Another one, which is Archetype, which is a high-level language with DSL. And between between SmartPy and Archetype, we can have LIGO. LIGO it's a language with strong specification. When I'm talking about strong specification in programming language, we're talking about types. So everything is verified. So once we do some operation, this is the same for Archetype and SmartPy, but at SmartPy, it's behind the scenes. It's not really clear. It's in LIGO, you have to define exactly what kind of data you're waiting for. What is the storage, what is the data type, so you define each data type and so on. So you have a strong definition. So this is increased, this help the design and also during the compilation of this language, how to say, use type checker. So during the compilation, everything is type checked. So once you want to use, for example, Tez, you cannot use naturals or integer. You have to use Tez. So everything is verified. This is the first thing. It's a multi-flavor language in order to cater develop the different developer, how to say, oh, sorry, I forget the word. So developer coming from, for example, from functional programming, the other one from imperative programming, and so on. And we can write contracts using, for example, something which looks like JavaScript, the one which looks like OCaml, the other one which looks like Pascal, the other one looks like ReasonML. So we try to attract different kind of population in a developer world. This is one high-level capability. And at the end, also, one important fact is the compilation should be improved and should, how to say, produce efficient code. When I'm talking about efficient code, we have two different aspects for efficiency. The first one is the code should be the smallest as the smallest as possible. It means that we should be sure that we are going to execute less code as possible. Why is important? Because as you know, once you run some code on the blockchain, you have to pay gas. Everything has a cost. So if we can, how to say, prove that the code which has been produced is the smallest one, we can also say that the gas is the smallest one. So this is really important because gas, it's a cost. Cost, it's money. So it's a cryptocurrency. So you have to pay. So this is one important role also the compilers to produce efficient code, efficient in terms of gas consumption, and also in terms of the size of the binary code which is produced, which is right now, which is Michelson code. So this is and every language try to do this, but this is really, how to say, in the DNA of LIGO, and it's always ongoing work because we have different aspects. The blockchain is not, as you mentioned, as you know, Tezos. It's how to say. Blockchain with capability to involve to be updated. So we have every 6 months or 3 months, I don't remember, a new protocol. So we have to deal with new protocol, new capabilities. That means we have to new optimization, new, for example, code which are running in Michelson are added in order to reduce the cost. For example, we have some high-level abstract operation, abstract obj code, so we have to use it. So it's a day-to-day work, and the optimization is it's a day-to-day work. And same for the language. Everything that should how to say. Have new features and so on, and we have to take care about the feedback also coming from the community in order to offer the best language as we can.
Okay.
So
I mean,
this is
it sounds like a very complex and very big job.
yes.
So in order to get that complex big job done, what can you tell us about the team that LIGO Lang has assembled and how it operates to stay on top of all of that?
Okay, so first, the team is not a big one because it's our something like 10 members, no more, no less, 10 members. And the work has been organized around the compiler, thanks to different layers. We identified 3 different layers, just in order to be sure that every people can understand the mechanism which are linked to each layer. For example, we have the front end, which is the high level, which is the syntax. So this is what the developers see, the syntax. We have we have some people which are really dedicated to this layer. For example, we have Christian Reden, which works on this layer and is really dedicated to this one because he spent a lot of time. We have a PhD also on programming language and mainly on parser and language analysis. It's really strong on this topic. But is not alone on this task. But mainly for me, it's a lead. It's a lead for on this topic on the parsing. We have the middle end, which is a type checker mainly. We have a lot of layer, but here I'm talking just of the high level and the most important layers. And so the second one is the type checker. So the type checker is the heart of the verification of the program. So each specification should be verified. So to be sure, as I mentioned before, that to be sure that you manipulate data correctly. And so this is the role of type checker. And at the end, so we have most of the people which are able to work on middle end, under the middle end and the front end. And the most difficult part is the back end. So the first layer are written with OCaml, Objective Caml, OCaml. We say OCaml right now. And the last layer is written thanks to Coq, which is a language with how to say, theoretical aspects. You can write some theorem that you can verify. You can have formal verification on your code, and this one mainly is done by 2 people. So as you can see, we have some different aspects, and some people are split. Some people work on different layer, but you have some, how to say, to sandbox where some people are really dedicated to this part, and mainly, for example, for the back end and the front end, you have different strong people working on this instrument, and the other one works on the different and helping the other one. Working on the language also means that we are working also for the how to say, the ecosystem, like package management and so on. So it's not really meant to do compilers. You also have to deal with package management and so on. So this is quite new because it has been designed in January, and right now we are trying to push people to work on and help the design on the libraries in order to increase also. So we have different aspects. So all these people are working on these topics to help and to help the design of the compiler. And you have different also kind of population. You have people coming from the academic world, which are like Christian, I'm pretty sure like Tom Jack also, which is we who work on the back end. We have some theoretical aspects and academic with the academic point of view. This is amazing because I have a long discussion with Christian this afternoon, and he explained me that academic people have a top-down approach, so a high-level approach, and going through deep layer and try to do some implementation. There were some people who came from much more engineer with a bottom-up approach, and so we can have different aspects and different people working with different approaches on the some projects. So and this helps really the design and the way we design the language, and we try to do it. Yeah.
Okay.
So this
So
is how it works, and this is
that's the, you know, getting the language ready and doing all the sort of behind the scenes stuff. But in addition to that, I understand increasing community adoption of LIGO Lang is also a priority for your team, which is a completely different kettle of fish, right? So I'm curious, what are your plans for driving adoption as 2022 rolls on?
So first, I think that the language is quite mature right now. So this is why right now we are pushing for the adoption. And so we have different approaches. The first one is to do some presentation, as we do right now, some meetups. So we try to organize some meetups in order to first, how to say, give some information and explain the capability of the language and the pro and cons of LIGO, comparing, for example, to SmartPy or Archetype. Because we should be aware that we should have we should deal with different languages. Each language has its own capabilities, pro and cons, and everybody should be aware of these pro and cons in order to choose the language with the right reason. Not choosing because it's Python, but because we would like given certain aspects of the language. So we have to increase the view we can the view of the language, the adoption, and the next stage also we are trying to helping and try to organizing some workshop and hackathon. So right now we have a dedicated what we call the developer relation, DevRel. I don't know if we use the same word in English, but in French
I've never heard that word before.
Yes, exactly. So the DevRel, we have in Marigold we have a DevRel which is dedicated to smart contracts and LIGO. Right now is participating to hackathon, which are organized right now. It's organized, which is organized in Germany. At the same time, we are working on workshops. So we are still elaborating some workshop for Tezos Israel at the same time, and we're going to work also for workshop in Tezos India. So we communicate a lot with different Tezos instances in the world, like Tezos America with APAC, Tezos India, Tezos in Gulf, so in Dubai mainly. So this is the first step for the full adoption.
So it's really about increasing awareness, right?
Yes, exactly.
And in the spirit of increasing awareness, we have an audience question here from Muradon, who asks, is there a quote unquote vanilla LIGO or just implementation with Pascal, Reason, and Camel?
No, it's a vanilla. In fact, each language has been designed which has been inspired by Pascal. It's not Pascal, it's Pascal LIGO. Okay, so for example, if you take the JavaScript in LIGO, you have to define types, which is not the case in JavaScript vanilla. So it's just how to say, has been inspired by this language in order to have syntax which are near the original one, but this is not how to say, JavaScript which has been compiled directly on Michelson. This is really a design which has been dedicated for LIGO. So we can increase the number of syntax, but once we try, for example, we are some expectation to do a Python-like, but we have to choose, just to show you the process, we have to choose which aspect of Python we would like to implement. And then after we do it, but we have to find the right essence. What is the, how to say, the right essence of Python? Do we want to have object-oriented programming? Do we want to have, for example, imperative programming? And once we have decided to decide to scope and the different aspect of the language, we can implement it. But this is we have to choose. We cannot do everything which is already provided in JavaScript. For example, JavaScript, you have no prototype. You have no capabilities to modify and to implement the prototype. So you don't have any capabilities to have a prototype-based language, which is a kind of object-oriented language, as we do, for example, in JavaScript. So we have to choose. So we choose the syntax in order to be sure that people are going to learn it quickly. And JavaScript just to target people who are already aware and they're already quite active in web application. And this is important because smart contract execution and the web application are really are strongly linked. So I think if we can attract this kind of population, it could be nice. Same as Python, because Python is mainly for data scientists. So we have two main population. The first one which came from web application, the other one for data scientists. Data scientists is much more like Python, and for the web is much more JavaScript. I don't know if it's a good response, to be honest.
Very thorough, very thorough. So all excellent stuff so far. I'm excited to learn more. Before we go even further into the nitty gritty, are you ready for the world famous TezTalks lightning round?
Yeah, let's go.
Great. Just before we do that, I'm going to announce today's keyword for the Tezos branded nano ledger we're giving away today. Today's keyword is !LIGO, L-I-G-O. Enter the keyword !LIGO in the live stream chat, and Nightbot will randomly select today's winner, who we'll announce before the end of the stream. Okay, now Didier, it's lightning round time. Remember, there are no wrong answers, and this is just for fun, so our listeners can get to know you a little better. Are you ready?
I'm ready.
Sushi or pizza?
So when I was young, it's much more pizza. But just after, I'm going to hate the pizza. But I really like sushi. But I would like to become finally, how to say, vegetarian. So I'm still pescatarian. So sushi.
All right. Beaches or mountains?
Mountains, of course. Yep. Sorry.
How many? Lightning, Didier. Lightning.
Oh, sorry. Lightning. Yeah.
How many languages can you speak?
2.
Is this
lightning.
Real? Okay. Is this real life, or are we in a simulation?
I would like to trust Philip K. Dick and the simulation theory. We are living a simulation.
All right, sounds good. True or false? Money buys happiness.
It helps.
It helps. I agree. Name one thing you absolutely want to do before you die.
Oh gosh. The first response is I would like to have my own restaurant, but this is not a good response.
Yes, it is. It's a great response.
No, my real response is I would like to be aware when I'm going to die, just to be sure that I can use my life at still the end.
All right.
I don't want to die during my sleep.
Maybe you can do both. You could do that and open a restaurant.
Yeah.
The last place you traveled was?
Morocco.
Morocco, nice. In 5 words or less, how would your best friend describe you?
Oh, I asked the question, and I have this response, which is open-minded, imaginative, curious. 3 words.
3 words, very nice.
Yeah.
And finally, what is your favorite thing to do on a rainy day?
Oh, I don't like, and Sunday, Saturday, Sunday, yeah, Sunday. And so it's a Sunday, it's a rainy day, so we can watch movies with my son. We are really fond of Star Wars and so on, so nice. I can see it once again. Or we can play games also with all the family, like Takenoko and so on. Or Parks. Parks is a really good game. Really, really good
Sounds
game.
like a great way to spend a rainy day. Thank you. Excellent answers. That's the end of the lightning round. Now let's get back to it. Tezos has recently implemented a protocol upgrade called Ithaca. From a computer scientist perspective, how has Ithaca made Tezos better?
Okay, so first, as you mentioned, I'm quite new, so I'm a newbie in Tezos ecosystem. But I try to give a response, which is this is not really original. I'm sorry. The big changes it was Ithaca is mainly is the consensus which has been replacing ME, which is named Thunderbeck. And this one provides, it relies on quite old but quite difficult consensus, which is based on what we call the Byzantine fault tolerance algorithm. So this is quite important. So, and this is the first aspect. The second aspect for me, which is really important also, is the number of tests which are required to become baker, because right now we reduced by 25%. And this is really important because if we do a comparison with Bitcoin and Tezos approach, Bitcoin is based on proof of work. And as we know, the how to say, mathematical aspects and challenge is getting harder and harder, and you have a kind of concentration of computation capabilities, so which is not really good for the distribution, because you are kind of centralization. And at the opposite, Tezos, once they reduce the number of tests which you require, you open the opportunity to increase the number of bakers. And this go to the other way, which it's try to have a kind of dilution of the power. So it's the opposite to Bitcoin. For Bitcoin, we have a concentration, and for Tezos, we have a dilution, which is really better for distributed system. So
Very,
this is
very
for me.
healthy for
This is
decentralization.
really important. Yeah, and in order to have this one, there's also the technical aspects that are instantaneous rewards for validators, so bakers, and finally everything has been targeted in order to increase the throughput of the number of transactions per second. So for me, if I would like to Thunderbeck is really important, but the capabilities to have this dilution is really important for me. If I clearly understand the aspects and the underlying aspects of the blockchain. So in order to increase the trust we can have on the system.
Okay. And as Andrew, you mentioned that LIGO Lang itself also goes through frequent updates.
Yes.
I think you said every 2 weeks. Is that?
That's right.
So why are those upgrades important, and how do they make building on Tezos more efficient?
So we have different aspects. You have each time we have a new protocol, we have to provide a new library. So as I mentioned, this library requires a lot of work. So in order to be able to use the right features provided by the blockchain, this is the first aspect. We have a day-to-day optimization. So we try to offer the most optimized code as possible, thanks to theoretical aspects, as already mentioned. We have a lot of feedback coming from the community. So once we have some issues is not only bugs, but it's also from propositions or evolutions. For example, it could be just a documentation, but it's also how to say evolution. For example, when we do some library, because once you decide to design a language, you don't know exactly how people are going to use it. So we are learning also based on the experience and the development experience done by the developer. And so we have a lot of feedback coming from the community, and a lot of questions. So the question raised maybe new issues and so on. So it's really how to say continuous work. It's a kind of I don't like to use this word, which it's look like agile approach. We have this is it's also in the DNA of the language, because once, for example, Christian, Gabriel, and so on start to work on this project, they decide to have a compiler which is designed step by step, not from scratch as we do. For example, we do some academic research. You do during a long period, you study the language and you try to elaborate the theoretical aspects, and then after you do the implementation. Here, this is not the case. They build from scratch day by day, and they increase. So right now we have a lot of, for example, RFC, which are what we are waiting for, but we have to implement it smoothly. So the language, how to say, of new features and so on. These 2 weeks help us to provide new language each time and so on. But at the opposite, we have to deal with deprecation and so on. It's really, really difficult to do it, frankly speaking. And this is why it's really, how to say, amazing. This is what amazing. So when you work on language, you have to think protocols. And for example, LIGO has a really nice feature, which is a test framework. So you're able to test your contract with a TDD. So if you know people who are working about the test-driven design, we can have test-driven design dedicated to contract this once you write contracts. So we can with all this approach, we have really, how to say, the same discipline as we have when you do some, how to say, traditional development. So this is the one of the responsibility of the team to give the best test framework as possible. And this is also a lot of evolution. For example, right now we are working on property-based testing and so on. We have mutation testing, where this is really, really tough. And finally, also, we have everything which is formal verification. And what we try to do is to have the backend right now, a lot of formal verification, but we would like also to have this kind of formal verification in the middle end. So we try to rewrite smoothly all the different layers from OCaml to Coq, but it takes time, and we need people to do it, and with strong skills on formal verification. So this is why we have a lot of depths, because we have a lot of aspects which are linked to the language. We have a compiler, but also in the compiler we have a lot of bricks which are small parts which are really how to say, tough and difficult to implement. So
Yeah.
the implementation is done and improved day by day.
Okay. I have a philosophical question for you. We recently interviewed a lawyer operating in the
Yes.
NFT space, and her position is that using the term smart contract, as we do in the blockchain world, doesn't make sense, since they're not really contracts at all. Can you tell us, can you define a smart contract for us, and tell us if you think that smart contract is a good name for what it is?
This is a difficult question. So what we can do first is to give the definition of what a contract is. So I googled the word and tried to find the right definition. So for me, the contract is it's a kind of a legal document. It's a legal document. So here first we have a kind of legal. So we have to define legal. What is legal? And this document states the formal agreement between two different people or more. Okay.
Yeah.
So in this sentence we have different aspects. We have agreement, the contract, which is the what we agree with, and legal. And as you know, the work of the lawyers is to how to say, to prove that is legal. This is his jobs. So right now, what is a smart contract? A smart contract is a program which is able to compute something, and which is also to able to do some transaction. Okay, and this transaction should be validated by the blockchain, thanks to the consensus and so on and blah blah blah. And the trust is given by the system, not by the lawyer. Okay. So for me, once you execute a program, you produce a data, and for me, the data is the kind of document. And once you decide to execute it, you accept to give some to execute this contract in order to obtain something, and this something should be validated by the system, and at the same time you can also have some transactions. So once you decide to accept computation and to have in return some data, these data are linked to the transaction, everything is validated. So for me, we accept that people are going to accept to do some agreements thanks to an execution, and these agreements, the legal aspect of the agreements is provided and proved by the blockchain. So for me, it's not once the contract produces data, the document is data, and so on. So for me, it's quite normal, quite logical to call it smart contracts. Smart because it's on the system, and the system do the job for you for the legal aspect. It's a very difficult question to be honest.
And you're saying it performs essentially the same function as any other contract, except that it just does it in a different way.
Mm-hmm.
Okay.
But once again, I'm a newbie, so this is my explanation as a newbie.
When she brought it up, I didn't know how to answer it, so I wanted to hear your 2 cents on it. That's great. We're at the end here. I'm going to announce the winner of today's giveaway of the Tezos branded Nano Ledger, and the winner is Yoda Master. Congratulations, Yoda Master. To claim your ledger, just email us at social@tezoscommons.org. We'll request a screenshot for verification that you're the account owner, and then we'll get your new Tezos branded Nano Ledger over to you as quick as we can. For those who missed out today, we remind you there are awesome giveaways to be found frequently here on the Tezos live stream, so keep tuning in. If you'd like to get in touch with us, our social media contacts can be found at tezoscommons.org/TezTalks. We'd love to hear from you. Didier, thanks so much for joining us today. It's always awesome to speak to the people working behind the scenes, building awesome projects like LIGO Lang and keeping us at the forefront of the blockchain revolution. Is there anything you'd like to mention before we sign off here?
No, I hope that I don't bring confusion, but much more clarity. But this is important for me. So I hope I was clear enough and in my explanation and in the discussion.
You have obviously a depth of knowledge in the field of computer science, so it's great to hear your perspective.
Thank you.
So thank you for joining us.
Thank you to you. Thank you.